The world around us is built upon tiny particles, atoms far too small to see. These atoms are the fundamental building blocks of everything we know, from the air we breathe to the stars in the sky. Each atom holds immense energy, a force unimaginable until the 20th century. This energy is what powers the sun and fuels the stars, a testament to the incredible power contained within these tiny particles. This energy, locked within the atom's heart, has the potential for both creation and destruction. It can light up cities or level them, depending on how it is harnessed. Welcome to Perspective of AI. This is the story of how we learned to unleash this power for better or for worse. Scientists around the world embarked on a journey to understand and control atomic energy, leading to groundbreaking discoveries and profound consequences. It's a story of scientific brilliance but also of terrible consequence. The same energy that can power our homes can also be used to create devastating weapons. To understand the nuclear bomb, we must first journey into the atom itself. By exploring the atom's inner workings, we can grasp how such immense power is possible. The atom is made up of even smaller particles, protons, neutrons, and electrons. These subatomic particles are the key to the atom's behavior and properties. Protons and neutrons reside in the atom's nucleus, while electrons orbit around it. The arrangement and interaction of these particles determine the atom's characteristics. The nucleus is where the atom's tremendous energy lies. This energy is the result of the strong nuclear forces that bind protons and neutrons together. Within certain atoms, like uranium or plutonium, this nucleus can be split apart, releasing that energy in a process called nuclear fission. This process is the foundation of both nuclear power and nuclear weapons, showcasing the dual nature of atomic energy. Imagine a single drop of water falling onto a still pond. The drop creates ripples, waves of energy spreading outward. Nuclear fission is similar. A neutron, a tiny subatomic particle, strikes the nucleus of a heavy atom like uranium. This impact causes the uranium atom to split, releasing energy and more neutrons. These newly freed neutrons then go on to strike other uranium atoms, creating a chain reaction. This chain reaction releases an immense amount of energy in the form of heat and light. In a controlled environment, like a nuclear power plant, this energy can be harnessed to generate electricity. However, in an uncontrolled environment, as in a nuclear weapon, the results are devastating. Nuclear fusion, in contrast to fission, involves joining atoms together. This process powers the sun and other stars. In fusion, lighter atoms like hydrogen isotopes, deuterium and tritium, are forced together under immense pressure and heat. This forces them to fuse, forming a heavier atom, helium, and releasing even more energy than fission. Fusion bombs, also known as thermonuclear bombs or hydrogen bombs, are even more powerful than fission bombs. They use a fission reaction to create the extreme heat and pressure needed to trigger the fusion of hydrogen isotopes. The result is a massive explosion, far exceeding the destructive power of fission-based weapons. From theory to terror, the creation of nuclear weapons. The theoretical groundwork for nuclear weapons was laid down in the early 20th century by brilliant physicists like Albert Einstein and Marie Curie. Their groundbreaking work in physics and chemistry opened up new possibilities for understanding atomic energy. However, it was the Second World War that tragically accelerated the development of these weapons. The global conflict created an urgent need for powerful new technologies, and nuclear research became a top priority. Driven by fear and the desire for victory, nations poured resources into harnessing the atom's power. Factories were repurposed, and scientists were recruited to work on this groundbreaking and dangerous technology. The Manhattan Project, a top-secret American-led effort, successfully developed the first atomic bombs. This monumental project brought together some of the greatest scientific minds of the time, working in secrecy to achieve a common goal. These bombs, fueled by uranium and plutonium, were dropped on the Japanese cities of Hiroshima and Nagasaki in August 1945, effectively ending the war. The devastation was unprecedented, with entire cities reduced to rubble in an instant. The world watched in horror as the unimaginable destructive power of these weapons became a terrifying reality. The bombings not only marked the end of World War II but also ushered in a new era of nuclear fear and the potential for global annihilation. A city vaporized, immediate effects of a nuclear blast. The detonation of a nuclear bomb unleashes a terrifying sequence of events. First comes the blinding flash of light, followed almost instantaneously by an intense wave of heat. This heat, reaching millions of degrees Celsius, vaporizes everything in its immediate vicinity. Buildings crumble, metal melts, and living things are incinerated in a heartbeat. Following the heat comes the blast wave, a wall of compressed air expanding outward at supersonic speeds. This shockwave levels structures, uproots trees, and hurls debris like deadly projectiles. The blast wave is followed by strong winds that fan the flames and spread the devastation even further. Silent killer. The lingering threat of radiation. The immediate effects of a nuclear explosion are horrifying, but the long-term consequences are perhaps even more insidious. Nuclear weapons release massive amounts of radiation, invisible energy that can penetrate living tissue and damage cells. This radiation can cause acute radiation sickness leading to nausea, vomiting, hair loss, and even death. The effects of radiation can also be long-lasting. Exposure to radiation increases the risk of cancer, genetic mutations, and birth defects. Radioactive fallout carried by wind and water can contaminate the environment for decades, poisoning the food chain and rendering vast areas uninhabitable. A heavy responsibility, knowledge, and the need for peace. In this section, we delve into the profound implications of our scientific advancements and the moral obligations they impose on us. The story of nuclear weapons is a cautionary tale. It is a narrative that underscores the dual-edged nature of human innovation. It is a testament to human ingenuity, but also to our capacity for destruction. The same knowledge that allows us to harness the atom can also lead to unparalleled devastation. We have unlocked the atom's power, but in doing so, we have unleashed a force that could destroy us all. This power, while a marvel of modern science, carries with it a grave responsibility. The knowledge of how to build these weapons is a heavy burden, one that demands responsibility and restraint. Scientists and leaders alike must navigate this treacherous path with wisdom and foresight. The horrors of Hiroshima and Nagasaki serve as a stark reminder of the devastating consequences of nuclear war. These events are etched into our collective memory as a warning of what can happen when power is misused. It is our collective responsibility to ensure that such events are never repeated. We must come together as a global community to promote peace and prevent the proliferation of these weapons. We must use our knowledge of nuclear science not for destruction but for the betterment of humanity. This includes advancing medical research, developing sustainable energy solutions, and fostering international cooperation. Thank you for watching Perspective of AI. If you found this video insightful, please like, share, and subscribe. Let's shape a brighter future together. The future of our planet depends on it. By choosing to use our knowledge wisely, we can create a world where science serves as a beacon of hope and progress for all.